All right, hello everybody. This is Miss Piekarski. This is your Unit 5 review. I'm going to record it and post it online. Please watch it before you come to class on Wednesday when we're having the test. For the test, you will not be able to use a 3x5 card, but you will be able to use your trig table and your trig identities sheet. So make sure you know how to use those. Make sure you study for the test. I don't think it's going to be very difficult. I'm going to go through several examples of the problems that are going to be on the test, or the type of problems on the test. So this is the first one, and you're just looking for the equivalent function for cosine A minus B. If you see this and you have studied your trig identities, you'll know that all this is your difference identity for cosine, and then you just need to match up the correct formula for it. Well, this one here, this is not the correct answer. This is the sum identity for sine. This one here is also incorrect because this is the difference identity for sine. The next one is wrong as well because this is the sum identity for cosine. But your last one is the correct choice because it is the difference identity for cosine. So if you look at your identity chart, you'll notice that cosine A minus B is, you can expand that to cosine A times cosine B plus sine A plus sine B. So really with this type of question, all you have to do is know where to look on your identity chart. All right, so the next one, find cosine x if sine squared x minus 1 divided by cosine x equals negative 1. With this one, you'll need to know how you can simplify this side of the expression as much as you possibly can. And so once you start doing that, you know that with sine squared x minus 1, you can replace the sine squared x with 1 minus cosine squared x. And then you'll have a minus 1 here. Simplify that further. In the numerator, you can get rid of your negative signs, your 1 and your minus 1 here. And I think I might have a typo on this problem. And then here you have cosine squared x divided by cosine. Even though you have this negative here, you can still reduce this answer by canceling out your squared term here and your cosine in the denominator. Okay, so when you do that, you end up with cosine x, and on this answer I forgot about this negative. So if that negative was still over here, you would have negative cosine x equals negative 1. So what happens with that is your negatives end up canceling out, and in this case cosine x would just equal 1. And there you have it. It's easy as that. So simplify this side of the equation, and this, you're just looking for what cosine x equals. Well, once you simplify the equation, you get cosine x, and it tells you it equals 1. Let's move on. All right, describe the transformations that change the graph of y equals tangent x to y equals negative 1/2 tangent times, or tangent of pi over 2 times x minus 4, and then plus 3 is at the very back. So this is kind of from the first part of Unit 5. You need to know what each of these numbers do to your regular tangent graph. So the first one is for the reflection. Because you have a negative out here, you're going to reflect across the x-axis. So everything that was positive is now negative on the y values. Okay. The translations, your minus 4 here has you moving to the right 4, and then the plus 3 here has you moving up 4. So for your translations, you're shifting horizontally 4 units to the right, and then shifting vertically 3 units up. You're stretching or compressing. The 1/2 here has you compressing vertically by 1/2, and the pi over 2 here has you stretch horizontally by pi over 2 units. Okay, now, so the stretch and compress, that has has an effect on the amplitude and the period. Excuse me, on the amplitude, most people see this -1/2 and say, hey, that's your A value, so the amplitude's -1/2. But you got to remember that the amplitude, oops, that should be 1/2. I forgot to change that. Your amplitude is, there you go. Let me change that. Let me fix that. Basically right here you need to be aware that the negative sign is not included in the amplitude because your amplitude is always the absolute value. So for here your amplitude would be +1/2, not -1/2. That's there in there to throw you. Now to calculate the period for this function, you should know that your tangent function, its normal period is pi. So to calculate your period, you're going to set up your equation pi divided by your b value, which is pi over 2, and then you multiply by the reciprocal, and you have pi times 2 over pi. The pi's cancel out, and so your period length for this one is just 2. Now remember, for sine and cosine, your normal period length is 2 pi, and so if you had a function that was just sine or cosine, you would, to calculate the period, it would be 2 pi divided by b. Hopefully you guys remember those from earlier in this trig unit. All right, next question. Next question is, which of the following is equivalent to cosine x? Well, you have a whole bunch of squared terms here. Several of these are squared terms, and then you have square roots everywhere. So you might want to look at your Pythagorean identities for this. If you recall, cosine squared x equals 1 minus sine squared x. But if you're looking for cosine instead of cosine squared, then you'll know you need to square root the 1 minus sine squared x. Well, anytime you square root that, you could always have a positive answer or a negative answer. So in this case, this is not going to equal cosine x. This one will equal cosine x. This one will not. And this one will. If you notice, this one and this one are slight variations from other identity functions. This one and this one are the two answers that you want. There are several different versions of the test. So some of you may have what's the equivalent of sine squared x. Some of you will have what's the equivalent of tangent squared x or something like that. Just look at your trig identities and become very familiar with them. All right, so next one, if cosine theta equals u, then cosine 2 theta equals what? Well, the cosine 2 theta, that's one of your double angle identities. A couple ways you can simplify that. Remember with our double angle identities, there's 3 different versions with cosine in it. However, you want the version that only uses cosine theta because that's all we know. And there's only one that only has cosine theta in it. Oops, I left it as an x instead of theta. Sorry. So for your double angle identity for cosine, the only one that just has cosine in it is the 2 times cosine squared x minus 1. If we replace cosine x with u, then we're going to take this whole thing out right here, just replace it with u, and we just get, oh man, I forgot the squared. Cannot believe I did that. This should be squared. So we get, make this bigger. There. So we would just replace cosine x with u, and we'd have 2 times u because cosine x up here is squared, the u is also squared, and then minus 1. Okay, so with this problem you're looking for, this is several different problems on the test. Suppose that theta is a rotation angle in the 4th quadrant and sine theta equals 1 minus 3 over 5. Find the other 5 trig ratios, okay? So this is going to be 5 different answers on the test. It is a multiple choice. Before we get started, we need to check and see what quadrant we're in. We're in the 4th quadrant, so our y in the fourth quadrant is negative, x is going to be positive, and in this case your r is also going to be positive. R should be lowercase, so R is also positive. Okay, we've solved problems like this a couple different ways. We can find our, we know that Y is -3 and R is 5 because of the sign ratio. We could also, and we need to find X. We could just find X using the Pythagorean formula, or we can use your Pythagorean identities to find what cosine theta is. And in this case, I'm just going to use the Pythagorean identity. So I'm going to have sine theta, or -3/5 squared, plus cosine squared theta. And that's set, and I'm setting that to equal 1. When I square this, I'm going to have to square these two terms and then subtract it from 1. And so that gives me cosine squared theta on its own, and then 1 minus 9/25 here. The -3 squared is 9, and the 5 squared is 25. And I'm moving that fraction over here, so it's 1 minus 9/25. To subtract a fraction, I'm going to have a common denominator, so the 1 becomes 25/25 minus 9/25, and that gives me 16/25, and that's what cosine squared theta is. I'm going to square root 16/25, and I get 4/5. But because I'm in the fourth quadrant, I know that my answer is going to be the positive version, not the negative version. Don't forget, anytime you take a square root, it can be positive or negative. So now I know that cosine theta is 4/5, so that would be one answer on the test. And then I'm looking for a tangent theta. Because I know that y is -3 and x will be 4, then I can just set up, I can just get my final answer of -3/4. But if I look at my quotient identities, I'll set this up as I'll set this up as sine theta over cosine theta, so -3/5, and that gives over 4/5, and that also will reduce to -3/4. For this one, I don't care if you use your identities or if you just set up your trig ratios. It's either case, it's fine. So with this, because tangent theta is a reciprocal of tangent theta, I can just flip this fraction. So I get -4/3, and because sine theta is the reciprocal of cosecant theta, I'm going to flip this fraction here, and I get -5/3. And then because secant is the reciprocal of cosecant, or cosine, excuse me, I'm going to flip this fraction, and it'll be 5/4. Okay. On your test, I think there's like an answer bank, and there's like 5 or 6 different choices. No, actually, I think I don't know how many choices there are to choose from, but there's lots of choices there to choose from. You just need to select the correct ones. All right, so this one type of question will have 5 different, or this one situation up here will have 5 different questions and answers for it. You'll have to figure out all of the missing trig ratios, okay? So we've done that a lot. I know it looks complicated. Don't sweat it. You've done it a million times. You should know how to do this. If you don't, come in for tutoring, okay? Now, I think we're almost to the end. Let me see. Yeah, this is our last question. So fill in the missing steps to prove that negative cosine squared, or 2x, divided by 1 plus sine 2x is equal to tangent squared x. So we just need to find the missing step. They already set it up for us. We have 1 minus cosine 2x divided by 1 plus cosine 2x. We're dealing with the most complicated side and simplifying it as much as possible. Now with this, the double angle identities for cosine, there's 3 different versions. So most of us, we don't know which version, but luckily for us, they've already set up, or they've already substituted what we need to substitute in for that right here. so we don't need to worry about that. And then we just need to figure out what happened between this step and this step. If you look, it looks like all of our ones disappeared. We need to figure out how those ones disappeared. Well, if you look at the numerator, you can go ahead and distribute this negative here. So you'd have 1 minus 1 and then plus 2 sine squared x. And then in the denominator, you can distribute this plus sign here. So it would be 1 plus 2 cosine squared x and then the minus 1. Okay, so if you, let me change that. If you look here, that's exactly what they did. Again, I know this seems super complicated. You just need to figure out what happened between here and here. And remember, this is a multiple choice test. And so look at, if you cannot figure it out on your own without looking at the options, look at the 4 options and see which one of those can be plugged into this situation. All right, so that's the end. I hope you find this useful, and please, please, please watch this. If you look on your Home Access Center and check your grade, you will see that you get bonus points if you watch the test review before you come in for the test. All right, I will most likely have you guys fill out some questions to get credit for watching the video. All right, talk to you later. Bye.